at Microsoft. My focus is on data platform. So for the CCG guys, how much do you miss this guy? How mad are you that we stole him?
I'm so
a
mad.
lot. So mad, right?
So mad.
Yeah, he's my spirit brother. We started on the same day, so we're like joined at the hip now. But anyway, so we're going to talk about Azure Data Lake Store, and I had this really great joke teed up about how if Databricks is Harry Potter, then Data Lake Store is like Ron Weasley, like not quite as cool, but still really important to the story. But I'm going to change it now based on Ahmed's presentation. If Databricks is Napoleon Dynamite, Data Lake Store is Pedro. So vote for Pedro because Data Lake Store is the workhorse of a modern data platform.
I'll have to rent the movies I get.
You got to see the movie, man. And here's the thing. If you commit to doing the dance, I will drive all the way back from West Palm Beach to come to the next meetup. All right?
We'll see.
All right, let us know.
Okay.
All right, so this is a reference architecture that we talk about a lot at Microsoft, and this is the modern data warehouse. And you know, we talk about data ingestion, data storage, prep and training, and modeling and serving. And the idea is in a modern data warehouse, we don't care what kind of data we're bringing in. We don't care if it's relational data, image data, blob data, video, whatever. The idea is that we need to land it somewhere, and that's where Data Lake comes into play. As Ahmed mentioned, Data Lake and Azure Databricks play very well together. And what we're going to do today is talk about why Data Lake, what Data Lake is, what the Azure offerings are for a Data Lake, and then some things about how to interact with it and work with it and provision it and things like that. Along the way, if you have questions, please yell them out. I hope that this is interesting enough that you guys are thinking about how maybe to use it in your own environments. So the first question we have is why Data Lake? So how many of you have worked with a data lake type environment or are familiar with a data lake? A few of you, okay, cool. So much as Ahmed had a history lesson, I have a history lesson. So for those of us that are old, like me, when we talk about traditional business intelligence, it always started with the question of what do you want to know, right? What questions do you want to ask, business user? And then we'd go create this really cool relational model, and we'd figure out how to load the data in via some really complex ETL pipeline. And then we'd go in and we'd create reports, and we'd serve them up. And that was great for a little while. But then somebody would come along and say, but what about X? And we'd have to say, well, the data warehouse can't handle that. We didn't bring that data in. We'll go get the data. Well, we didn't load the data because we didn't think we needed it. But I want to know this answer. Well, sorry, dude. Let's go spend 3 years redesigning the data warehouse and the overly complicated, probably very expensive and fragile ETL pipeline that we've built. And so what ended up happening was the business was demanding the ability to decide what they needed to know after the fact. And technology is just now starting to catch up. So now if we talk about big data and a new way of thinking, here are some things that we hold to be true. All data has value. We may know what its value is today, but tomorrow, other data may have different value. There may be data that we think is meaningless, that all of a sudden we care about. We want to be data hoarders. We want to be the people that refuse to ever throw anything away. We want like the 50-foot high stack of newspapers, in the closet, and we refuse to throw them away even though we're a fire hazard. We want to hoard our data. We don't want to have to invest in defining schema around data, defining definition of it, until we know how we want to use it. And we also want to make sure that we can impose a schema, one or more schemas even, at runtime. So like almost just-in-time modeling. And we call this schema on read. And for me personally, coming from the relational database world, being a person who grew up in third normal form and then eventually, the Ralph Kimball School of Data Warehousing, this was a lot for me to deal with. I think my therapist had to talk me down from the idea that we were going to store data in its raw format and worry about it later. I didn't do well with that, but I'm on board now, and because I've been able to see the business value in it. And then users get to use the data as they see fit. If Ahmed's in doing something cool with Databricks, he doesn't want me defining how he interacts with the data. He does not want me defining pretty much anything with the data. I can't be trusted, let's be honest. So now we have this different way of thinking. We get all the data we can. We put it somewhere and we say, we don't care what it looks like, what it is. We're going to store it for as long as possible. No retention periods, no purging processes, none of that. Then we're going to allow analysis over different definitions of it, different schemas using different tools. We're going to get results and we're going to continue to iterate. This type of structure is actually more in line with how business users want to make decisions. We're not funneling them down into some predefined structure that we decided on before we really even understood what the business needed. So when we talk about a data lake as the solution to this emerging need for schema on read and indefinite data storage, there are some things we have to make sure we take care of. We have to check these boxes. We have to handle security. If we're storing all the data all the time forever, there's a chance there's something in there that is sensitive. So we have to make sure we're highly secure. We have to make sure we're not having to worry about scale. How many of us have done capacity planning on hardware at some point in our career, where we just basically ended up throwing the dart at a wall with a number, and we said, oh, I think it'll be 100 gig or 100 terabytes by. Yeah, see, you know. It has to be reliable. If I'm hoarding data, I can't lose data. That defeats the purpose. I have to make sure that I can manage throughput. I have to be able to spin up a Spark cluster and do performant analysis over it. I have to be able to store data in its raw format. I need to be able to store it in its, I wanted to say, data provenance. You'll hear this term a lot. It's sort of like Antiques Roadshow when they're trying to figure out if the painting is really a famous painting that was hidden in like somebody's great aunt's attic. So data provenance, our ability to trace it all the way back to the very beginning. We need to be able to not care what the data source is. I don't care if it's a picture or a video or a JSON document or an object coming out of a database. I need to just be able to say, cool, come on in. And then I have to be able to support multiple analytic frameworks. Today, Databricks is what everybody's talking about. A year ago, it was HD Insight. 3 years from now, who knows what the analytic framework is. The most expensive thing that you can do in data engineering is move data. So I need a platform that allows me to land the data somewhere and persist it for as long as I want to. Those are the requirements behind Data Lake, and that's why we've invested so heavily in Microsoft in this technology and made it such a big part of what we do. It literally sits in the middle of most of our modern data architectures because we say we don't care where the data is coming from and we don't care where it's going. Data Lake Store can handle it, which sounds magical, but it's pretty cool, I promise. Did you want to get a picture? Okay, are you good? Stop me next time. Any questions on sort of the history and the foundations and why we have this kind of technology out on the Azure platform? Everybody good? Okay. So now what we're going to do is we're going to talk a little about Azure Data Lake Store. So Azure Data Lake Generation 1, Generation 2 is it in public preview now? It's in public preview, and we'll talk about that. But Azure Data Lake Generation 1 has been out for a couple of years. It's really interesting. This was one of the first times before I became a Microsoft employee, realized that Microsoft was serious about open source. Because the Azure Data Lake Store offering is built on Hadoop file system. It uses Apache Yarn as its resource negotiator. We have a language called USQL, which is .NET and T-SQL had a baby, and that became the language, which is also extensible by C#, R, and Python. And then we have the ability to interact with Data Lake Store via, Spark, Hadoop, Storm, a lot of other different tools. So this fundamental, basic, scaled down architecture was Generation 1. And it works. It works beautifully. I'm going to demo on Generation 1 today. But the Data Lake strategy has evolved. So for any of you who work with Microsoft technologies, you know that it is very confusing when you talk to people and they say, should I put that in blob storage or in Data Lake Store? Because we basically have the same use cases and the same story around those. And that wasn't just an issue that our customers were having or our partners were having. It's an issue that we were having. So internally, we have combined those engineering teams, and they're working together now. And so in the past, all we had was blob storage. And blob storage is great because You have high availability, you have ability to scale, and it's really cheap. And then we brought in Azure Data Lake Store as a parallel offering, and it's very performant, and you've got really great security features, which we'll talk about in a minute. Generation 2 brings those together. So we have that scale and availability, still really cost effective on blob storage, but it's still really fast and it's still very secure. So what we're going to do is we in Generation 2 are combining Data Lake Store and blob storage to create a single product, essentially. So key features. Before we get into this particular bullet list, basically Generation 2 is Azure Data Lake Store with Azure Blob Storage underneath instead of HDFS. But what's really cool is we have the ability to use the Hadoop compatible APIs to still interact with blob storage. So it's what we're calling bimodal. So I have underlying Azure storage, but I can interact with it as though it were HDFS or as though it were blob storage. So if you're coming off of Generation 1 and you want to move to Generation 2, you can keep the APIs that you have. If you're setting up a brand new Data Lake Store, consider using the blob storage APIs because there's some real benefits there. We have atomic file and folder operations. This is what they're calling hierarchical namespaces. Basically, we have the ability in the file and folder structure in the Azure Data Lake Store to point right at a particular object rather than having to scan. So we're going to get better performance. Fine-grained access control lists, which you say ACLs, but I don't like that. It sounds silly. But basically, I can set permissions at the file level, make it recursive, folder level, just like I would in on a file system of any kind. Limitless storage, literally you can scale out to anything. Pricing based on Azure Blob Storage instead of on the original HDFS storage. So you're going to see parity between the Azure Blob Store storage account pricing and the Azure Data Lake Gen 2 pricing. So it's pretty inexpensive. It's already pretty inexpensive, but this pricing model is even better. We're going to be in all regions, and it's going to be optimized for Hadoop and Spark. So everything that Ahmed talks about is going to work beautifully with Gen 2. Briefly, this is one of the things, I just brought this up because I want to talk about the hierarchical namespace. This is a big deal. So I can use my blob APIs, I can use my HDFS APIs, and I get this hierarchical namespace that didn't exist before, which basically gives me almost like an indexing process over my data. So as we're scaling this thing out and growing, I have the ability to get into that data very quickly. All right, so we're going to provision a data lake briefly, and then we are going to come back and check on it in a few minutes. Oh no, I'm already here. So this is my Azure portal. You guys are all familiar with Azure portals? Cool. So what we're going to do is we're going to go in and say create a resource. Search on Data Lake. I'm going to say create. We're going to put it in a new resource group. Oh, whoops. Encryption settings. By default, my encryption keys are managed by Azure. You have the option to use Azure Key Vault. You have the option to not enable encryption. I highly recommend against this. One of the benefits of Azure Data Lake Store is you have encryption at rest and encryption in motion. So unless you are absolutely 100% sure that nobody's ever going to put anything in there that anybody cares about, go ahead and use keys either managed by Azure or in your own key management system. So we're going to leave it at Azure Managed. We trust those guys. All right. And we hit create. And it's that simple. Like literally, that's all you have to do to provision a data lake. Behind the scenes, it's going on and doing a lot of really cool stuff. But as far as actually doing the work to provision, this is it. So the great thing is it's really easy to provision. Sometimes the downside is that it's really easy to provision. There's really not a lot of use case in a single organization to have multiple data lakes. We encourage you to maintain your data in multiple states inside a single data lake. That's what the file and folder structures are for. So it's really easy for people to go all create their own lakes. We would encourage you to maybe have one global lake, and then have folder systems and security to manage the data that goes along with it. So while that's running, and you can monitor it up here, see deployment in progress, we're going to come over and talk about a few of the features that go along with a data lake. There we go. So you'll notice one thing we didn't do was specify a performance tier or a size. Because basically what happens is we're going to go provision the nodes. Think HDFS, you have a multi-node system. There's sort of natural partitioning. So basically this thing is going to scale with you. You don't have to remember to go scale. It's going to scale as you add more data to it. It automatically integrates with Azure Active Directory, which is really nice. And you can have a file that goes up to a petabyte or more. I mean, why you would have a petabyte size file, I have no idea, but I'm not judging. But if you wanted one, you could put it into your data lake. So how does it work? So, how many of you are familiar with HDFS? Cool, so we'll walk through this. So I have a file, right, and I add it to my Azure Data Lake. What it's going to do is it's going to slice it up into blocks, right? And then it's going to distribute that block across multiple nodes. And then what's going to happen is metadata about that file is also going to be stored. So when I go to retrieve that file, it has parallel processing to go retrieve the different parts of it, reconstruct it, give it back to me. So that allows me to scale very, very quickly, and it allows me to write very fast. And we get massive throughput. Because it's all sliced up into different blocks, when I go out to read, I'm not going to a single location. I don't get the I/O constraints that I get like on a traditional hard drive. And so multiple small read operations rather than one large read operation are going to let me execute things in parallel very, very quickly. All right, so because it's HDFS and because pretty much all of Azure works this way, we're going to maintain 3 replicas of each data object. So on locally redundant storage, and each of those replicas is readable. So I'm writing to a replica, I'm committing to those replicas, but when I go out to read, I may hit any one of those replicas, which is cool. So basically, I've already tripled my read capability on this thing. And this one is important. The data is never lost or unavailable, even under failures. So like, let's say replica 3 goes down. It's going to run off of replica 1 and 2 while it's going out and building up another replica. And then what it's going to do is once that replica is up, it's going to synchronize everything and keep going. So you have really good fault tolerance with an Azure Data Lake Store. So now, let's talk about the tools you use to interact with it. But before I go, does anyone have questions about any of this so far? Are we good? Yeah.
Does Gen 2, does that have geo-redundant storage available now? Or?
I don't know.
Okay.
I haven't been hands-on with it yet. I've looked at the architectures, but I haven't been hands-on. But that's a great question, and we can talk offline, and I can follow up with you on that one.
Okay, thank you.
In the back?
You mentioned not to have multiple data lakes, just to have one global data lake. Would there be any use case scenario where you actually have multiple data lakes?
Regulatory, maybe. I mean, if you had truly independent workloads of some kind and you were absolutely sure that there was a performance benefit or it made sense to keep them separated, I mean, as a data architect, I would fight for a single data lake because it just keeps everything simple. And what we see a lot is the data lake can be my landing, staging, pre-production, machine learning results location all in one place, and I'm still connecting to the same data lake. But if you've got regulatory requirements where you've got to keep data separate, or either because of privacy or geography, as well as if you just really know you have 2 completely different workloads, then...
If you have them separate, is there a way to bring data across one to the other?
Yeah, I mean, we can move the data between the 2. I don't know of an automated tool to do that, but... Yeah, you can probably use AZ copy to bring them across, but I haven't done that before.
Thanks.
Yeah.
Do you support ASIC?
ASIC.
Yes. So I believe because this is a distributed system, you are following the CAP theorem. So you are not able to do transactional and have everything that we usually have in a relational database.
So the question was,
Acid.
could you spell
ACID.
ACID? Oh, yes, actually, let me go back. So rights are committed to application only after all replicas are successfully updated. So it is a strong consistency model across all of the replicas, not an eventual consistency model. Now, if we're thinking about ACID transactions, and for those of us that don't come from the transactional world, that's atomic consistent.
Atomicity, consistent, isolation.
Isolated, and what's D stand for? Does anybody remember? What's that?
Durable.
Durable. So it has a lot of the same characteristics. It doesn't advertise itself as an ACID model, but it does have a very strong consistency model in terms of write commits.
Eventually.
I think a big question.
No. Rights are committed. So the application can only get at the data after all three replicas have been committed to.
Yeah, I agree, but it's eventually, the consistency is eventually. There is a moment that the database, or whatever you have, the data that you have there, is not consistent.
There will always be some latency between the replicas, but the application can't get to that data until it's been written to all three. That's what I'm saying. That's why I'm calling it a strong model.
So what he's really asking is if USQL, T-SQL, and .NET put together, does it have the same syntax of begin transaction, commit, and rollback? If it doesn't have that syntax, you're not an ACID database. Because you can't roll back or...
Right. That's a great question, and I cannot remember the answer to it. But I will find out for you.
So kind of in that same vein as like multiple users, if you have multiple users sitting in your data lake at the same time, how does it deal with that integrity?
So one thing I want to make clear is Data Lake is not a replacement for a relational database. Data Lake sits in front of our relational databases. So I'm going to go back and...
Okay. I was trying to come up with an analogy, and you actually compared it with a hard drive, and I'm thinking it's really just storage, right? It would be with a
It
really
is.
fancy,
It's storage.
Protocols and encryption and stuff on top of distribution. It's just like a hard drive.
Yeah, we have tools over it.
Yeah, but you're not putting any, so there's no format requirements, therefore you don't know what format it's in unless.
Yeah, I want to go back. This is an important point, and this is how we end up with what we call data swamps, where we're overusing the technology for the wrong purpose. So we're ingesting the data, we're storing it. We have a lot of flexibility to store this data, right? But we still want to model the data. At some point in this workflow, we're still going to model it. We're still going to put it into a relational database 9 times out of 10, whether it's an Azure SQL Data Warehouse or an Azure SQL database or even an on-prem database. We still want to do that modeling. What we're doing is we're saying we're going to capture this data, we're going to secure it, we're going to keep it for as long as we want to, we're going to allow our data scientists to work with the data to get us results that we want to have ending up in, say, Power BI. But really, this is about capturing the data at its source, right? Ultimately, we still want to bring the data back into a relational model.
But that's outside of the data lake.
Outside of the data lake.
Yeah, and if you had like unstructured data, you wouldn't even be doing it.
Well, I mean, I might take my unstructured data and put structure over it, or I may take my unstructured data and use my prep and train process to create structured results off of it. So when we think about moving the data from our sources across to something where our CEO is looking at a donut chart, right? 'Cause that's the best chart, right? Donut charts?
Sprinkles on them.
Yeah, the data lake is a critical part of that path because it allows us to capture and interact with it with a lot of different tools, but it is not a replacement for a relational database. Is everybody cool with that idea? Does anyone have any different use cases or thoughts? And be careful. How many of you are app developers? Nobody? Okay, you're kind of. You don't get to pick. All I'm saying is,
Won't commit, but
I'm warning you in advance because I've lived this story. Your app developers are going to go, wait a minute, I don't have to worry about referential integrity. I don't have to do anything but write some USQL or hit an API to go interact with the data. And they're going to try to stay right here and start building applications off of it. And there may be good use cases for that, but do not let it become a crutch for them, because they will use it to avoid having to go hit the relational databases that have ACID transactions and have referential integrity and all the other things that go along with it.
I don't want to talk too much, but it's that double error there coming from data lake to model and serve is kind of the thing. And you can write to the data lake from your application, right? So,
Yeah, sure.
so you
And
could
if we have
probably
time, if
mess
I
up-
don't run out of time, I'll show you guys PolyBase.
So you could pollute your data lake if you're not careful.
Absolutely. Well, yeah. I mean, bad data in, bad data out. You know, there's still governance. There's still process.
Not just the source data, but anything that's done to it.
Exactly, and that's something to be very careful of. And I love that you guys are asking these questions, because this is a technology that makes it very easy to just get lazy, right? So there has to be discipline around what is the purpose of a data lake, and it is to capture that data in its raw state cheaply and quickly to allow us to do other great stuff with it, not to have it be the end point of our data in most cases. So I'm going to jump back real quick. Just to keep us on track, because I've got about 15 minutes, right?
Yes.
Okay. Lots of ingestion tools. You can upload directly from the Azure portal. PowerShell, of course, is ubiquitous. You can talk to anything with PowerShell. There's a really great Azure Data Lake SDK that is for Visual Studio, so you can go and develop in Visual Studio, tie into your GitHub or your BSTS or whatever. Command line interface, Azure Data Factory, ADL copy, other open source tools that are out there. For building pipelines, again, we've got Azure Data Factory. We can stream data directly into our data lake. So if you do have streaming data, like say data coming in off of sensors, IoT, things like that, Data Lake is a great way to capture that data using something like Stream Analytics. Again, open source PowerShell, and then our SDKs and our REST APIs. And with Generation 2, remember, this is not just HDFS REST APIs, but also the Blob APIs are available for us. So what I want to show you briefly is, I'm going to go to my own, oh look, our deployment succeeded, yay. I shouldn't act surprised, I haven't had it not succeed, but. So this is our data lake. A couple of things I want to show you real quick. So I have about 8 gigs sitting in my personal data lake. So far this month, I have spent 31 cents. So data storage is cheap. It's when you start computing that it becomes a little more expensive. When you start having ingress and egress and computing over that data, then it's a little more expensive. So I was going to make a terrible joke. Data Lake Store is less expensive. Databricks is more expensive, right?
It's always the
I'm the
computer.
bargain. My product is the bargain of the two. But.
It's like buying a laptop.
Okay, so one thing I want to show you guys, and I encourage you to go stand one of these up. It won't cost you anything except for a couple of cents. Throw a couple of files in there and go look at how like access control, encryption, firewall settings. You can create Azure Resource Manager templates off of your configuration so that theoretically you could like tear it down and build it back up without having to build it manually. But we also have our Data Explorer. And so from the portal, I have the ability to go see everything that is in my data lake. And theoretically, I can go in and upload a file, and I can browse. I have the ability to go and say, okay, for this CSV, I want to set access on it. And remember, my access control lists are at file and folder level. So I can go in and I can add users. We have AD integration, so I'm going to assign, since I've got Jeff and Ahmed here, I can assign these guys to my,
Make sure it's the right Ahmed.
not the Egyptian pop star.
Yes.
We were in a customer meeting the other day, and I was talking about this, and I asked him which email address was his, because there's 2 A Sharifs, and he said one was like an Egyptian pop star. I don't know. You're AH. Maybe slow because there you are. So I can add Ahmed as a user without having to do anything other than go and hit my AD account. But what's really cool, and this is what I want to show you guys very quickly, is that the portal's great. I actually prefer the Microsoft Azure Data Explorer because it's going to let you have a desktop-based application where you can go in and manage all of your storage accounts. So I can go in here and I can still see my data lake stuff. I can go and upload from here. I can set permissions. I can create security keys and things like that. So like if I go in, I don't want to do a folder.
So it's just Windows Explorer.
Oh, upload files. There we go.
Yeah, one or two.
Yeah, it's all the same. So I can go ahead and just push a file up manually. And again, I can do it through command line, I can do it through SQL, I can do it in a lot of different ways. The other thing we have is Visual Studio integration. So I have my Cloud Explorer here. I have the ability to go in and say, Open File Explorer, and I get basically the same functionality. So it's sort of wherever you're working, you have the ability to go after the files and see what you've got in there. And you see it looks a lot like Windows Explorer, right? It's folders and files.
In File Explorer, can you take a quick look at the data in its raw form?
Absolutely.
Yeah.
Thank you for that. It's like you're a plant because I forgot to say that. So yeah, I can go in and say I want to look at my customer data, and I can actually get a preview of the data. I can go in and look at it. I can set expiration on it as well. So if I do have impermanent data, I can say I want to hang on to this file for 30 days or 60 days or whatever. Okay, so how much time do I have? I got like 5 minutes. Tons of time. Let's talk security for just a second. The thing everybody gets really excited about. Security is the best.
Except when it's not, yeah.
What's that?
Security boring, except when it's not.
As I mentioned, full Azure Active Directory integration as well as Databricks. So Databricks and Azure Data Lake Store can talk to each other through AAD. We have role-based access controls for account management and ACLs at the file and folder level. We have diagnostic audit logs that allow us to go see who's accessing files, when they're accessing them, things like that. And we have encryption in motion using HTTPS and transparent server-side encryption using either service-managed keys or customer-managed keys. Briefly, the AAD integration does allow us to do multi-factor. Integration with on-premises AD for federated authentication. So if you've got an on-prem AD and an Azure AD and they're federated, we have the ability to leverage that. Pretty much the same thing, but the security monitoring and alerting that goes along with AAD is nice. So encourage your people to use AAD and have it set up and configured properly. Okay, ooh, I have 5 minutes. We're gonna talk about PolyBase for a second. Who knows PolyBase? PolyBase is the best. So PolyBase is this feature that came out with SQL Server 2017. It has now been added to Azure SQL Data Warehouse, and what it does is it allows us to, from the relational database, call out to Blob Storage or Azure Data Lake Storage or Hadoop File Storage and create an external table and then treat that data in that table as though it were part of the relational database. So basically I can have data in a database, data in my Data Lake Store, and I can write a single query that brings those all together without ever having to move the data out of the Data Lake Store. I know, right? It's awesome. So yeah, so what we see a lot, one great use case for this is cold storage, right? So we were talking to a customer just the other day that said, we have 5 years of data we want to get out of our database and put in cold storage. We're like, hey, put it in Azure Data Lake Store, create some external tables. You're not going to get the same performance, obviously, but you can write the same queries, and you can age that data out of your relational database. So it's really cool, and it's a way for us to move data between, say, I wish I could just like have a second screen with that same modern data warehouse. If I'm pushing data from my data lake, right? So I have loaded my data into Data Lake. I've done some modeling and training on it. I've done some really cool stuff with it. Now I'm creating a data warehouse. Rather than having to physically move that data via like Azure Data Factory or something like that, I have the option to use something like PolyBase and just write SQL as though I were moving the data. It's almost like going back to the old school ways of writing ETL processes. So what I'm going to do briefly, I'm so excited I have time for this. What I have here is an Azure SQL Data Warehouse. So you can see here, if you guys can see that, it has the little multi-node icon. I will warn you in advance, if you want to play around with this, probably play around with an on-prem SQL Server 2016 or 27 instance, because Azure SQL Data Warehouse will blow through whatever your Azure budget is. So I turn this on and then I'll probably turn it off before I leave the room here, because it is costly to run an Azure SQL Data Warehouse on my personal account. But what I did was I have an Azure SQL Data Warehouse, and what I want to do is I want to go query a file that I have sitting in my Azure Blob Storage. So what we do is we create, hang on, let me go back here. So what we do first is we create a database scoped credential, and this is a little tricky. And if anybody's interested in trying this, there's some good walkthroughs online in our documentation, because what you have to do is basically create an app in Azure. You have to grant that app access to the Data Lake Store via a secret key. And then you create a database scope credential on your Azure SQL Data Warehouse that says this is the identity. So it's my app ID at my OAuth token for that key, and then my secret. I changed this. This isn't really the secret key to my Data Lake Store. But you create a database scope credential, and then you create an external data source. So I can do Data Lake Store, Hadoop File System, Azure Blob Storage. Since Data Lake Store sits on HDFS, the type is Hadoop. That's always confusing for people. And I'm basically giving it the address of the data lake where I have my file located. And then I'm giving it my database scope credential that gives me permissions to go talk to that Data Lake Store. Then what I do is I go and say, okay, now I know I've got a file that I want to bring in, so I create a file format. So I say, okay, my CSV files are going to use comma-separated, single ticks for string delimiters. This is my date format. There's some other options you can have in there. So I'm basically defining the file that's going to be coming across. I also did a TSV file format. And then what I do is I create an external table. So let me show you real quick. If I come back over here, this is actually the file that I'm going to bring across. See if it'll talk to me. Let's go over to the portal. It's nice to have options. So this is my file. It's just a list of currencies, right? Really straightforward. So what I've done, and I'm lazy and didn't give this file a header, so I've got columns 0, 1, and 2. No. Oh, that's my Storage Explorer catching up to me. So now I'm going to go in and say, I'm going to create an external table. I'm going to call it dim currency external. I'm going to define my columns and my data types. This is my schema on read, right? This is the point at which I say this is what the data type in the table structure is. So I left that CSV file just hanging out there. Now I actually want to use it. This is my schema on read. And I tell it where it lives, so I give it a relative path off of my data source. I tell it what file format I'm going to use. And then what I can do is I can go query that file directly off of, fingers crossed that I didn't break anything. It's probably my firewall.
Yeah, if you make that. Security.
Yeah, security.
And security will block you.
Hang on. Oh, I'm not connected. Hang on. Okay, we're going to do this quick. CCG, I'm adding you to my firewall rules, so.
You're official.
If you get a transport level error, it's usually the firewall rule. So there we go. Okay, so I have queried my external table, right? and I've selected my data, and I'm treating it just like a regular table. It lives over here in Explore in the external tables folder, so you can see it. And a good pattern is to use the create table as select pattern to create basically a staging table. So if I actually want to load this into my data warehouse, what I might do is this kind of pattern where I say, you know, drop my table, create table, as select. This distribution round robin has to do with the MPP structure of Azure Data Warehouse. I'm telling it where to actually put the data in which nodes, but that's another conversation. But anyway, so now I'm querying that data and putting it into a local table, and now I've staged my data directly off of blob storage without actually having to write a real ETL process. And I was able to define that schema like right there in place as I was developing this. Does that make sense?
The table is created in your relational database.
Pardon?
The table is created in your relational database?
Yes, it's in my Azure SQL Data Warehouse, which is a relational database. It's a massively parallel processing relational database, but ultimately, yes. All right. Thank you for your great questions. I appreciate it.